The broadcast is now starting. All attendees are in listen-only mode.
Welcome to today's webinar. This is Jeremy Henick from Isograph. I also have Joe Belland on the line from our technical support team. Joe will be doing most of the demonstration of the software today. Today we'll be taking a look at Weibull and how to use your historical data in the Weibull software. You can use Weibull as a model type for your failure properties to accurately model your system. The Weibull software is included with several of our software products. It's included with AbSim. It's included with RCM cost in our availability workbench software. It's also included as part of our Fault Tree Plus software and our RBD software. This is the 6th webinar in a series that we've been doing on how to use your tools. Most of these have been in our analytical products. Weibull is.
Jeremy, yeah? If you have slides, could you please share your screen?
Oh, yeah. Sorry about that. Is that better?
Yes, there we go. Thank you.
Okay, just going back. Let me just go back a couple slides then. So just to go over to that again, in our availability workbench software included in AbSim and RCM cost. In our reliability workbench software is included in RBD and Fault Tree. This webinar is the 6th in a series we've been doing. If you've missed some of the earlier webinars, I have recorded all of the webinars and have posted them on our blog. Our next series will be moving into simulation. Weibull will be covering a little bit of simulation today as well. Weibull is our one software product that sits in both analytical and simulation tools. If you'd like to view past webinars, you can go to our blog. It's blog.isograph.com. There's probably, you could spend days in there watching movies and reading technical data if you'd like. One piece of information before we get started, there's quite a few people in the meeting today, so everybody's muted. However, you'll notice there's a pop-out pane for the webinar software. You can minimize the pane by clicking on this little arrow. However, if you have any questions that you'd like to ask during the web meeting, please post them in this questions dialog here. And either I'll answer the question to you directly, or I'll post the question for Joe to answer during the web meeting. He'll be pausing throughout the meeting to answer any questions that might come up. And I'll go ahead and hand controls to Joe. Joe, you got that?
Yeah, just a second. I have to get the right monitor. Okay, so you should be able to see my screen. You should be able to see the Reliability Workbench software. As Jeremy mentioned, the Weibull module is available in both our Reliability Workbench and Availability Workbench packages. It's actually kind of unique in that it's the only software module we offer that's included in both packages. It actually basically functions the same in both packages as well. Computationally, calculationally, it's the same in both. Although the feature set is a little different because it's tailored. It's tailored to support the analysis that you would do in those packages. So the version of Weibull, Reliability Workbench, has slightly fewer features than the version in Availability Workbench. So to start off with, I'll go through the Reliability Workbench version so we can see how the basics of it, and then I'll point out some of the differences in the Availability Workbench tool. The Weibull module is, again, it's one of the modules that's available in the package. So you get to it from the module selector in the Reliability Workbench screen. But as Jeremy mentioned, it comes with the Fault Tree and the RBD. So if you've purchased either the Fault Tree or the RBD module, it comes with Weibull as well. So it's not a separate license or a separate purchase. Okay. So when I jump over to the Weibull module, what I get is the Weibull screen. Now, the point of the Weibull, what we're trying to do here, if you've attended some of our other webinars, we've talked about building fault trees, we've talked about doing famicas, I think we've done a little bit of RBDs. One thing that you'll notice is always an input is the failure data. So when we did that building a fault tree from a schematic, I drew the schematic and then I had to put in failure data into the representing the component failures into that fault tree schematic. And that's the part that kind of throws a lot of people. Even if they have the schematic or even if they know how to model their system, they get to the point where they need to do the probability calculation. They need to run the analysis, but they don't know what the inputs are. They don't know what the quantitative inputs should be. Now, there's a few ways around that. The prediction modules, reliability prediction modules, are one way of accounting for that. Parts libraries are another way. But perhaps the best, in terms of most accurate way, might be the Weibull module. What this will do, what it's designed to do, is take historical data. So it calculates a failure rate for a component based on historical failures for that component. So you might not know the failure rate for a particular component, but if you have a work order history or your maintenance crews have been tracking how often do they do planned maintenance or how often do they do unplanned corrective actions on a piece of equipment, you have that history available. You can use that to calculate, or excuse me, you can use that to have Reliability Workbench calculate a failure rate for you for that component. So let me just show you how that works. So basically, then the Weibull module is a module or a program to calculate failure rate based on historical time to failure data. So to begin, I'll need to add a new Weibull dataset. Click on the Add Weibull Dataset button. A dataset is just a collection of time values, Weibull time to failure data. This could be all the failures for a particular piece of equipment, for a particular component in an assembly. It might be data for a particular failure mode. How you choose what data you'd want to analyze would probably be oriented toward your goal of how you're going to use this in the fault tree or in the ABSIM or the RCM cost. So for instance, if this is going to be attached to a particular RCM cost failure mode, you know, a drive shaft shears is one of the failure modes in one of our example projects. Then your Weibull dataset would be failures or work orders pertaining to that particular failure mode. If it's more general, if it's just a generic, you know, cooling system fails is your basic event in your fault tree, then your Weibull dataset would be related to failures of that cooling system. So the Weibull set contains data relevant to the basic event or the cause or the block that you're using. Okay. So I've created a new Weibull dataset. Let's say this is some sort of failure, like valve fails open or something like that. That might be the failure mode that I'm interested in. The analysis tab just has some options. We don't need to really go through these, but what I do want to mention is the two methods, method 1 versus method 2. There's two ways of inputting data, and I mention them because they're relevant for the next tab we're going to look at. Method 1 is where you can enter the life, the age of the components when it failed. How many hours or how many, the time units again are, the program doesn't really care. So how many hours old was it, or maybe how many days old was it when it failed. The second option, the method 2, is where you actually enter the date information. This might be more relevant if you're entering information from a work order history. You have the date of the installation, and then you have the date of the failure. The program will just subtract those two dates with the lifetime, the age of the component before it failed. Okay. So I'm going to do method 1 for this, and then I'm going to jump over to the items tab. The items is where I enter the Weibull sets items, basically, the times to failure. So this is a valve fails open. So let me say that enter some times that it failed at. So basically what this data would represent, suppose I took 10 valves and ran, and maybe it was under test conditions or maybe it was in the field, I ran them for a certain amount of time, and I just recorded how long it was before each one failed. So one failed after, say, 5,000 hours. Another valve failed after 7,500 hours. Maybe another one failed after 8,000. And say 8,300 and 8,700. I'm just, again, sort of picking numbers here. And then maybe more at 9,600. And then at 10,000 hours, we ended the test. So we had 1, 2, 3, 6. We had 4 remaining. So I'll put suspended, which means we removed them from service. They hadn't failed. So we had 4 that lasted 10,000 hours with no failures. Okay. So what that suspension checkbox means is that the time value doesn't correlate to a failure, which just means the item was removed from service and it's still working at that time. So those time values from components that are still working should count towards our, the reliability of the components, but it's not a failure point. So that's it. So I'm saying I had 4 suspensions at 10,000 hours. Okay. The disabled checkbox, if you're wondering, just removes that time value from consideration during the analysis. You can use that to turn off a time value, basically remove it from the analysis without having to delete it. You might do that if you think, if you imported this data from the work order history, and you think maybe a couple of them don't really apply or are not relevant for the particular component failure that we're modeling here. Okay. Okay, so I've entered my time values. I click OK, and let me hide the grid. Here's the grid view of the same thing. And yes, you can enter and edit the information here as well. But let me just show the plot for now. So it plots the time values as the red dots on the Weibull plot. The Weibull plot itself is a log-log plot where the x-axis, the independent variable, is the time value. The y-axis is the unreliability. What percentage of the components will we have expected to fail by each time value? Okay. So then what we can do is we can choose from the main toolbar at the top, we can choose a Weibull distribution to match to the data points. So the default is a 2-parameter Weibull. What that means is that the program will calculate the eta and beta, characteristic life, and shape parameters for the Weibull curve. To have it do that, I just click the red eta icon, calculate distribution parameters automatically. The program will calculate the line of best fit, or curve of best fit technically, since it is a long plot. It calculates the curve of best fit that matches the data points, and then it will display on the right-hand side the parameters that define that Weibull curve. So an eta, a characteristic life of E4, so 1, 2, 3, 4. So 10,560 hours is our characteristic life. Our beta, our shape, is 3.773, which means there's a sort of a steep wear out on that component. It will also give a couple of goodness of fit and error indicators. So the row value, that symbol is there, is the Greek character rho, is the correlation coefficient. So a higher value is means a better fit. So 96% correlation. The epsilon, that's the Greek character used there, that's the error indicator. The error indicator indicates about 4.97% difference between expected and actual values. So those values are actually pretty good. It means that the curve is a pretty good fit for the data values that I've entered. Okay. So now that I've calculated, some people will be just interested in that aspect of it, just calculating the values. Oh, and by the way, I didn't mention it, but you can choose different distributions to match. So this is a 2-parameter Weibull. I could do an exponential curve as well. An exponential is a beta value of 1, basically a flat failure rate. But as you can see, there's kind of high error, and just looking at the graph, it doesn't really fit that well. This data very clearly has wear out. 1 parameter is where you can specify the beta, the shape parameter, and it will calculate the best eta. And 3 parameters where it will also calculate the gamma parameter, location as well. That would be most relevant if you're dealing with a data set for a failure mode that does not start at the beginning of the component life. Weibayes is similar to Weibull, except it's most commonly used for data sets with very few failure points. So I'm going to go back to my two-parameter Weibull. So again, we have the parameters, and some people might say, yep, that's great, that's all I'm interested in, just want to be able to say what the failure rate for that component is. But really the true power of this comes in supporting the other analyses, the other modules within the respective packages, Reliability Workbench or Availability Workbench, because this Weibull dataset is now available to you in the fault tree, in the RBD, the RCM cost, and the AVSIM modules of the respective programs. Because generally that's what you'd want to use it for. I mentioned that you've built your fault tree, but you don't know what failure data to put into it. So we import a work order history. The Weibull module calculates the failure rate. So let's go ahead and apply this to a fault tree. I jump back to the fault tree module. So this is my cooling system example fault tree. This is one of those examples that you have in the when you install the program. It installs this simple cooling example. So how do we use this Weibull dataset to quantify the failure rate in the fault tree? Well, you can attach it to a failure model, either a local failure model or a generic model. I'll create a new generic failure model. Again, this will be my valve fails open failure mode. Now, to attach it, if you choose the model type as Weibull, you'll get a little drop down on the right-hand side here. You might notice this. This drop down here allows you to choose from any Weibull dataset you've created. It'll show a list of every single Weibull dataset existing in this project. So you can choose a Weibull dataset from your list. Right now I only have one. And it will automatically fill out the the relevant calculated parameters, the characteristic life and the shape in this example. It's kind of hard to see on my monitor, but I'm not sure how it's showing up on yours. But it also grays out those fields, so you don't, you can't type in those fields. It sets them and then grays them out. You can still set other things like the intended repair or the test typical. So okay, so now I've set it's calculated that value for me. And click OK, and now I can apply that failure model to a basic event. And now when I say I don't have actually in this one there should be a valve somewhere. The top level here, we've got to actually have a couple of valves. Oh, those valves are closed. That's the opposite failure model, or failure mode to the one I want. But if I had a valve fails open, we'll just pretend it's valve fails open, I can apply this failure model to fault tree basic events. Now notice those eta and beta parameters. Those are coming from that Weibull dataset. So any updates I make to that Weibull dataset will automatically be reflected in this fault tree basic event. It's now, this fault tree basic event's data is now tied directly to that work order history that went into the Weibull module. Okay. Jeremy, this might be a good time to break. Are there any questions that have come up so far that you'd like me to answer?
Yeah, you might have addressed this already, but in the actual Weibull set, can you automatically fit the distribution? And if you don't like that, can you choose which type of distribution you want to use?
Yeah, so in the automatically fit distribution, that's actually one of the features in the availability workbench, where we'll choose from a few different Weibull distributions to fit to it. Of course, you can always just choose the one. If you don't like it, you can choose your own. But we'll see that in the, I'll point that out in the availability workbench.
Okay, thanks.
Okay. Okay, so now that I've applied that Weibull dataset, I can run the analysis, and it calculates the fault tree basic event probability directly from my work order history. Okay, so that's one way to do it, is to directly type in the dataset items. That's also I also call that the boring way to do it, because if you have, let's face it, if you have a list of 50 or 100 or 1,000 work orders, you're not going to want to sit there typing in every single one by hand. Fortunately, the import wizard, if you've used the import feature, the import wizard can tie into the Weibull module, so you can import data that way. There's actually even a simpler way using the clipboard. You can actually copy and paste Weibull dataset items into the Weibull module. Let me just show that. I have an Excel spreadsheet here. Again, this is also an example Excel spreadsheet that comes from software. If you look in your reliability workbench or availability workbench directories in your My Documents directory on your computer, there's an import and export files subdirectory, and there's a couple of CSV files in there. One's called valves.csv, that's what I have open. The other's called pans.csv. Those are just example data that can be imported into the Weibull module. So I'm just going to select this. This is just basically a list of times to failure. Now, this particular data sheet is very simple. It's just times to failure, but there could be extra information. There could be the work order ID. There could be a suspension or failure, or a column that indicates whether it was a suspension or a failure. There could be extra information that I can import. But for now, I'm just going to import those times to failure. So let me copy that onto the clipboard. Okay. And then I'm going to jump back to the reliability workbench. Give it a minute for it to update on your guys' end. Okay, so to paste this into the Weibull module, first I need a Weibull dataset to paste it to. So I'll just add a new one. This will just be generic valves failures, valves to correspond to the data sheet. So I'm going to paste it into this new Weibull dataset. I also have to make sure I show the grid. So let me set it to plot and grid, because I'm going to be pasting into the grid view, basically. So I can just right-click on the grid and say paste from clipboard. Also from the grid menu, the same option exists, paste from clipboard. So let me just do that, and it will take me through a simplified import setting. Basically, I'm running an import from the clipboard. And again, the import feature has a lot of options, a lot of things you can set. But in this case, it's actually very simple. On most of the options, I can skip over and ignore. All I need to do is tell the program what I'm importing. So I say I'm importing that clipboard data into the Weibull set items. That's the data that I'm importing, is Weibull set data items. And that particular, those data values that I'm importing represent time values. So those are the only two settings I need to make. Tell me what table and what field. I mentioned if my spreadsheet had additional information like work order number or failed or suspension, column to indicate failures or suspensions, I also have to match those columns up as well. Then once I'm done, I just click the Import button. You'll notice populated the grid in the background. It says Import Complete. And it fills in the plot with those time points. And again, I can just match the two-parameter Weibull curve to it, get a new eta and beta, and now I can, again, just apply this to the fault tree. Okay. Any more questions, Jeremy, before we move to availability workbench?
Yeah, just one, just to understand the differences. Normally, you see failure rates by year and hour, but in this example, it's showing eta and beta.
Oh, right, yeah. So about the units.
Yeah.
I've been talking about entering the time values in hours. So the Weibull parameter beta is the shape of the curve. So that doesn't have a unit. Eta has a unit. So the units for eta will be the same as the units for your time values. So in this case, I think these are hours. That's the only way I can make sense of this data. 25,000 hours before failure. So the eta value here will be the characteristic life in hours. So 12,390 hour characteristic life. Again, generally speaking, the Isographs products generally don't care what units you're using so long as you use them consistently. And the Weibull module is no different. It doesn't care if you enter your values in hours or in days or in years or in miles, as some of our users will do, just so long as it's consistent. Okay. Now let's jump over to the availability workbench, so we can see a little bit how it differs, how the Weibull module differs. So right now I'm in the RCM cost. You probably may be familiar with RCM cost or with the AVSIM. If you have either of those modules, you will also have the Weibull will be included with that license. Now here I have a different data set, a fan motor data set. Again, it's similar data to the valves. Actually, I think it's the same data except off by an order by one order of magnitude. We simplified it that way. Find my Weibull data set items that I've entered in, and put on the plot. And so it looks a lot the same, but you will notice I do have additional distributions that I can choose from. So I still have my exponential and my 1, 2, and 3 parameter Weibull. Well, the main addition would be normal and log normal, and also the phased and regular bi and tri-Weibull distributions. Let me just explain those two. I think normal and log normal I think are easy enough to understand if you're familiar with stats. If you're not, you can just look at those distributions on Wikipedia. But with the bi and tri-Weibull, what it basically will do is instead of calculating a single Weibull curve to fit the data, it will calculate 2 or 3 curves that match the data. And you might use that when it looks like the data is due to multiple different failure modes. Each one has its own Weibull sets. So, for instance, if your component exhibits infant failures, useful life failures, and wear-out failures, those are 3 different failure modes. So we might apply 3 different Weibull curves, each one to model a different one of those failure modes. If I choose the bi-Weibull, it's actually calculating parameters for 2 different Weibull curves, and then summing them. Basically, what you do is you sum them to find the failure rate. It matches okay, but if you look at the data, it kind of looks like there's a break there. These first few points are a little flatter, and then it comes up at the end. Maybe we can try a phased bi-Weibull. So the difference between the bi-Weibull and the phased bi-Weibull. Bi-Weibull just sums the 2 Weibull curves. Phased bi-Weibull is basically a piecewise defined function, where you use one Weibull curve up to one time value, and then you use the second Weibull curve after that time value. So you can see there's sort of a break, a bend in the, or a corner in the curve where it switches from one Weibull data set to the other. And as a result, it kind of more custom tailors it to fit the data. So there's a tighter fit. You can see that it's reflected in the error indicator as it shows a tighter fit. There was that question about the fit distribution automatically. There's that select distribution automatically. It tends to just, when you use that, just use the option that gives it the greatest number of degrees of freedom. So what I think it's doing there is actually choosing between the 2 and 3 parameter. I believe it tends to go for the 3 parameter Weibull just gives the highest degrees of freedom. And again, the 3 parameter, the difference is that it's now calculating a gamma value. I don't think this is really relevant. It's giving a negative gamma value, which is not usually what 3 parameters are used to represent. And again, it is just the best fit because it's high degrees of freedom. I actually kind of like the bi-Weibull. I think it would be phased bi-Weibull for this one. It looks like the line very closely matches the data. Okay. Most of the other options within the availability workbench are the same. You have the same paste from clipboard option, so you can import data in the same way. The data set itself has many of the same options. There's a couple other extras as well. I'll mention some of these options here as well. Oh, let me refresh that. There we go. To apply it to the RCM cost or AVSIM, it's done in a similar way. I go to the RCM cost module. I can apply it to an RCM cost cause. That's actually this was a fans data set. I think they have a fan system. Air supply system. Here we go. Fan motor burns out. This is actually where I think they're being used. I double click on my fan motor burns out cause on the failure tab. Yeah, you can see I've already set it. In the cause properties on the failure tab, there's an option where you can choose your Weibull set from the drop down, or use the binoculars to search through a list of them if you have a lot of them. Okay. And again, when you choose that, it automatically sets the distribution and enters the the eta, beta, and gamma parameters. It grays out all the fields, and it will manage that. So if any changes you make to the Weibull dataset, changing the distribution, adding additional data points, anything that you change on the Weibull side will automatically be updated and reflect here. So I can click OK, and then when I run the simulations, it will be basing the failure probability for this cause on the Weibull dataset, and works similarly for AVSIM. If I jump to the AVSIM module, on the you enter via failure models, similar to how we did it in fault tree. In both the fault tree and RBD in reliability workbench, you entered through a failure model. It's the same thing in AVSIM. You create a new failure model, and on the failure tab, choose the data set like we did in the RTM comments. And then this failure model can be applied to a block in the RBD block diagram in the AVSIM, or if you're using a fault tree in the AVSIM, you can apply it to a fault tree basic event. Okay, again, I'll pause here. Any questions, Jeremy?
Just a couple questions on importing data. I think that you plan on getting to that later in the meeting, though.
No, I can answer them now. Because I'm only I'll talk about the importing with the SAP board, but if there are any other import questions, I should.
Yeah, like what are some examples of places to get this type of data?
Right. Yeah. So. Yeah, that is actually a lead into the next topic, which is the SAP portal in Availability Workbench. Actually, before I get to that, I'll answer that question in just a second. I do want to show just one more feature. If you're wondering what these B and P values are, these are both in both the Reliability Workbench and the Availability Workbench. It has the it's called the B life and the P parameter. You might have noticed those again also in the analysis options. With those, what those represent, it's kind of a quick calculator. B life is I give it a percent, and it will give me a time. P value is I give it a time, and it gives me a percent. What that means is if these B values have entered percentages of 10, 15, and 20, and what the program will tell me is at what time will 10, 15, or 20% of units have failed. P is just the opposite. I can give it a time, and it will tell me what percent of units will have failed at that time. And those values, those calculations are shown up on the right-hand side. That might be useful if you want to know. Say, if I run this component to 10,000 hours, what are the chances that it's not going to make it? If I try to get it to 10,000 hours, and the B parameter is the opposite. If I want to replace it, the component. Before 10% of failures before 10% of units have failed, what time would I need to do my preventive maintenance to replace it so that there's only a 10% chance it will have failed by that time? So that's why I can use those two parameters. Okay, but to answer that question about where does this data come from, I mentioned work order histories and things like that. So it would probably be from either field or lab test data. You may record that information in a spreadsheet. I mentioned work order history. If it's work order history, maybe that's being recorded in, say, a CMMS system like SAP or Maximo. And if so, if you do have that data in an SAP system, then you can very, very easily import that information into Availability Workbench. Let's show how that works. For this one, I'm going to revert to an older version of Availability Workbench, version 2.1. The SAP portal in this version is a little bit older. It's been updated in the latest version. But the reason I'm using the older version is because my SAP data for the older version contains Weibull data. I can show you version 3, but then I don't have any good Weibull data to show. So I'm using the old version of the SAP portal. So if you've got the AWB 3.0, you'll notice this is an old version of that portal. So the SAP portal, again, allows you to download data and upload data back into your SAP system. And again, there's also a similar portal for Maximo as well, if you use the Maximo system. So in this particular system, I have a snapshot of an SAP data image Of course, I have various different components and equipment, functional locations in my SAP system. I can also download spare parts and labor categories, texts, and things like that from SAP. One of the things I can also get is the work order history. I go to the Analytics tab in my SAP portal. It shows me a list of all the different locations in my SAP system, at least this is my test system here. I can choose one of those, and it shows me all the work order history associated with that functional location. So most of these are not very good data. The work order data is the same as the previous or the start. It's not really a filled out data. But I have it here. I have a few work orders. One up here where it's for two different components, and it looks at the work order history. Basically, what's the date of the work orders on a particular component? When it sees that component has two work orders, two or more, it will compare the time value from one work order to the next. It uses that as time to failure. You can also look at the category of the work order. Was it a failure work order, or was it a planned maintenance? And from that, it can determine whether or not it was a failure of the component or a suspension, whether the time value was failure or suspension. So once I have all this information, there's some of the different work orders. These are planned replacements. I have all these different values. I click the up at the top. I can click the calculator button to calculate times to failure in preparation for download to a Weibull dataset. It calculates the time to failure again based on the previous work order date and the current work order date. It uses that to establish a time to failure, and then I can just click the download times to failure to an availability workbench Weibull dataset, and it will create. It says Weibull dataset K1 updated in the current AWB project. Okay. Minimize this and there's availability workbench. I want to make sure I have the right version of it. I'll jump over to the Weibull module, and I have a K1 dataset. It created it, plotted the failure points. There's more than just failures. There's also suspensions. Because remember, a lot of those work orders were replacement work orders, or PMs. So it did it based on install date, so you can see the install date and a failure date. It also copied across a reference ID, which I think refers to the work order number. And then, of course, the time values as well. All that's left for me to do is just calculate the distribution parameters. I can have it do it automatically. Try for a free parameter, which actually looks like it fits the best. Kind of a high error, but the correlation connection is good. Okay, so I've matched that data, and then I can then go about using this in the RCM or ABSIM. Jeremy, any questions on that?
None that I'll bring up. Any questions that get posted that I answer individually, I probably won't bring up in the meeting, but we'll follow up with all those in emails afterward.
I will just briefly show the SAP portal in Availability Workbench 3.0. That's what this version is here. The SAP portal is a little bit different. It's now a module within the Availability Workbench rather than a separate window. And I'll just point out where the options are. There's still the calculator, calculate TTFs, and build the Weibull set. The reason I didn't do it here in AWB3 is if you, in my particular SAP snapshot, I don't actually have any time to failure. The work order history is not properly filled out in this SAP snapshot, so the date values are not correct. So I don't have any time to failure data. But it's still the same options: calculator and then the build Weibull set. Okay. I think that's all I had to demonstrate, Jeremy, unless there's anything else that you can think of that I should show.
No, that looks good to me. That we're just about out of time anyway. Let me just put my screen up here really quick. So again, my name's Jeremy Henick. Joe Bellin gave the presentation today. Here's my contact information. I'll be sending out another email in a few weeks to finish up this series and start into our next series. If you have any questions or would like to suggest web meeting topics,